Welcome everyone to the executive stage at DSC Europe 23. My name is Danica Marinkovic and I will be your host today. I would like to welcome you on the behalf of the organizing team of DSC Europe 23. We are happy that you are joining us at the biggest AI event in Europe. I would also like to use this opportunity to thank our partners Ananas Gold, Rivian, the World Bank, and Bosch, without whom this conference would not be possible. Without further ado, I would like to introduce to you the first keynote speaker at DSC, Anja Baresic, Researcher Associate at Ruđer Bošković Institute, Laboratory for Machine Learning and Knowledge Representation. She holds a doctoral degree from University College London and undergraduate degree, Division of Biology, Faculty of Sciences in Zagreb. She wrote numerous scientific papers such as methodology challenges in studying human gut microbiota, effects of collection, storage, DNA extraction, and next-generation sequencing technologies. Anja, the stage is yours.
Thank you very much. Good morning, everyone. And seeing this is the first talk in the morning, I will try, A, not to give you an academic lecture, and B, try to stay at a very high level, talking about AI in healthcare. And I think the idea would be to first go through how about we do it in Croatia, and secondly, then spark a little bit of a discussion at the very end. So feel free to barge in, ask questions halfway through the talk, etc. Okay, so why am I here today? Well, I'm here today because we tried to build a very comprehensive Croatian digital healthcare ecosystem, which is based on AI innovation. Okay, do you have digital healthcare in your country? Some people are saying that. Okay, cool. So do you know what these guys are? These are the prescriptions, and on the right-hand side are the paper version of referrals. Okay, so we lost the left ones in 2011, and we lost the right ones just about as the COVID pandemic was starting in 2020. They were actually they were being deposited in someone's drawer up until that point when they realized they need them very, very quickly. So we could say in Croatia we kind of do have a digitalized healthcare. At least it's mostly, by and large, paperless. But it's at the very beginning of that path. Okay. At the same time, our industry is actually, besides tourism, which is obviously a very big problem, there's a quite interesting, vibrant, and very high-level populated ICT sector. And on top of that, our partners, Croatian Association for Artificial Intelligence, has done first in 2019 and then in 2021, this project that is called the Croatian AI Landscape, where they actually map everyone who is involved in AI research, AI industry, creating products, or in any way linked to the AI world. And I think this is a really nice idea of actually starting to build an ecosystem of its own right. We obviously have, there you go. We obviously have the two unicorns most people know about, that's Infobip and Rimac. We have well over 100 startups. They also identify the problems with this ecosystem, which is that it's very much heavily based on the capital. And also there is a chronic lack of female founders in this world. Okay, so this is the companies and startups. There's quite a few of them I don't necessarily need. This is actually on the website, so you can actually go there and see all of these companies. But also, what's quite interesting, they mapped all the early adopters, so the people who can't call themselves maybe AI experts at the moment, and they also mapped all the enablers, the standing ecosystem, the academic community, the artists who are involved in it, and all sorts of other incubators, accelerators, etc. Okay, so we have a strong AI culture and a community in the country. We have we're pretty much digitized healthcare. So what does that mean? Well, you know that AI is used, I'm not going to teach you about, I'm sure a lot of other talks today and yesterday will be about specific issues that can be solved by AI in healthcare. They're numerous, okay? However, us coming from the academic community, what we do, and our lab actually covers AI in various domains stemming from biology, medicine, maths, computer science to arts and economy, we read papers on AI topics, right? And if you map all the papers that come out there, so the research output, the dominant category is actually healthcare. Right, so it's the really cool topic to apply it on, right? Okay, I have 2 small children. When you go in a GP practice, how much AI do you see there? Well, none. Okay, so there's clearly a problem between the academic research stemming from technology transfer and commercialization to get to the product that that the society has the benefit from. So at some point, Europe decided that the next age will be the age of digital and the age of green. What they did, European Union funded a huge amount of money, they pushed in a huge amount of money of over 9 billion euros into this digital Europe program. And what they said, there's 4 main skills that are now being developed and should be used more in the society. Advanced digital skills is going from the level of actually writing on a piece of paper to kind of basic digital skills. Cybersecurity and trust lacks in all aspects of society. Artificial intelligence, which we see a boom of, and this is why we're here today, and high-performance computing, right? And then for all of that, for all the expertise to actually penetrate into society, they built this pillar called digital transformation and interoperability, and within that, they built projects, they built specific consortia and specific set of projects that revolve around this newly termed European Digital Innovation Hubs. We call them EDICs, okay? So as of 1st of January 2023, there's a network of 150 new EDICs created in Europe. The idea is that every country chooses one of these expertises and one of the domains or a few of the domains specifically to that country, and that the country edicts actually digitize the part of society based on the local needs. And that gets funded from the central source, okay? So Croatia has 4 edicts. I am the coordinator of the one called AI for Health, CRO. I think it's pretty obvious we try to innovate with AI in the domain of healthcare. The other 3 cover some other topics, and also we are in the region, we are probably the only one that focuses exclusively on healthcare. Okay, so what does that mean? Every edict is supposed to provide services to their users, and in our case, we needed to choose a specific focus, that's smart healthcare, which is digital healthcare, and medicine, and based on our expertise. So Institute Ruđer Bošković and all the partners we involved, our primary expertise is AI, with several decades of expertise in AI, and also that AI sometimes needs to be enabled via means of high-performance computing. So if you can't calculate on your own machine, you need supercomputers, and you're not going to buy them on your own. They're going to be provided for you on a larger scale. Okay, so our partners make relevant experimentation facilities available, and we make sure that they're available to all of our users, okay? The other thing is for our users, which are mostly startups, we offer a seamless service to the large European startup communities like Enterprise Europe, Network Startup Europe, and all the other edicts. Remember, they chose us, so each region has specific topics and they're not overlapping in the neighboring countries. So if we don't have some expertise, we make sure to send our users to another edict that actually does. And also, what is quite specific to our consortium is that we try to help European Commission develop legislative and regulation in those specific topics, and that is AI world and healthcare data, okay? So this is typical for all edicts. Our customers are tailored for SMEs and mid-caps, so for startups, and for the public sector. In our case, our public sector are the hospitals, the ministries, the insurance companies, so everyone who is actually involved in this whole ecosystem of healthcare. And every edict has to offer these 4 types of services: testing before investing, support to find investments, so we don't provide the investment, we are actually just helping them get there. Skills and training, you can appreciate that this is a very interdisciplinary field, and building this innovation ecosystem and networking beyond this ecosystem. So we're funded with about 3 million euros, and the way the system works is that half of the money comes from European Commission, from Digital Europe program, and half comes from the member state. And all of this money will be used for performing those services for our customers, who at the end pay 0. So half of them they get through state aid, half of them is co-funded by European Union, and they get all these services for free. Okay. So even by European standards, we are a really large edict. It's a consortium of 16 different companies, 16 different entities, sorry. At the very top, you have a Ministry of Healthcare here, who is supporting us because they need input from top up, from the bottom up, sorry, to actually see what this industry needs to actually get on the market. There's the only insurance provider for public healthcare in Croatia, which is Hrvatski zavod za zdravstveno osiguranje. There is a Croatian Institute for Public Healthcare, which is the resident institution that is a handler of our healthcare data on a national level. There is 2 healthcare organizations that have previous experience with piloting and testing AI technologies in their own environment. Magdalena is a cardiology clinic, so it's an example of a secondary care center. And Dom Zdravlja Zagreb Center is Zagreb's union of 80 GP practices, so the largest GP center in Zagreb that has previously been piloting certain advanced technologies in their own practice. Here's the Ruđer Bošković Institute as the coordinator, and also a department with experience in AI and HPC. Technical faculty in Rijeka with, up until very recently, the largest HPC resource in the country, and medical school of Split, who are actually willing to teach their students about AI, which I think is pretty much groundbreaking. There's Croatian Institution for Croatian Association for AI, Employers Association of healthcare employers who are actually keen on teaching those skills to their members. There's 3 partners that are actually providing knowledge on the business aspect of the whole startup world. Zagreb Incubator, Feels Good Capital is the only Feels Good Capital Partners is the only regional VC fund that focuses on social impact projects, and Mreža Znanja is there to help in project administration, project management, and writing pan-European projects. And also these 2 providers are the basis of our digital healthcare. They are the ones who have actually implemented the whole system that the digital healthcare of Croatia lies on, and this is the only company in Croatia that has actually managed to develop their product and get there on the market with their AI solution. And you hear about it more later. So these are the partners on European level and the world level. And just to kind of point out who we are at the Ruđer Bošković Institute, I come from the Laboratory for Machine Learning and Knowledge Representation. Like I said, 15 researchers that apply to anything, everything, and develop various AI solutions, and recently focused a lot on trustworthiness of AI and the validation in different concepts. And Center for Informatics and Computing, who provide a HPC resource and are a national competence center in the HPC world, and a member of EuroCC consortium. Okay, so I'm not going to teach you about AI models in medicine. I'm sure you can teach me a lot of things there. But let's just go quickly through the basics to kind of just remember. It's a process. It's a well-known process that has 5 steps. Well, you can kind of roughly divide them in 5 steps. It always starts with asking an interesting question, right? And this is usually the problem that I have with quite a few projects, that they come with either exploratory idea, but they don't know what question they're answering, or they define a question which is frankly not interesting to anyone but themselves. Then comes the data part. The blue part is all about the data, getting the data, exploring the data, and modeling the data. This is something that I think everybody in this room knows quite a lot about. And then communicating and visualizing the results. I think you can appreciate that especially steps 1, 2, and 5 are very specific and very different in a healthcare domain than in other domains, right? What is the interesting question? How do you get the data, healthcare data? And how do you communicate and visualize the results so they're actually useful to someone and they end up using them as opposed to what they're using so far? Because remember, doctors are creatures of habits. They do this, they follow protocols, you have to persuade them that it's better than what they do so far, and their investment of time and money in learning the new thing is worthy of their time and money, which they lack massively, okay? So this is something I like to show to all of the students. What do you need to do all of that? You need a team. Because someone who is very good at computer science, excellent in maths and statistics, and also knows, in this case, very well the medical domain, is pretty much a unicorn. If you ever find one, please send them our way. We want to employ them. I don't care if they're students, they're postdocs, they're senior researchers, or they even want to just lead the projects. Please, please. So what you need teams. You need teams of people. Just to visualize the process in slightly more detail, again, I don't want to go through all of the details. This is just talking from the data perspective. And if you focus on 3 different kinds of experts that you can have in this team, you can appreciate that what you need is a mixture of them along the entire pathway. So they need to talk to each other, they need to be willing to work together, and they need to understand each other. And therefore, you need to train them, because there's not enough of people of these expertises on the market, and they're not used in working in teams, okay? Just quick overrun. I like this definition of AI best, that AI is something that thinks rationally based on the data you taught it on. It acts rationally if the thinking is linked to some kind of mechanics or some kind of action. It can think humanely if it could work completely like a human brain, which I will argue that it doesn't exist at this point in a moment, no matter what TV and newspapers told you in the last few months. And also acting humanly would rely on thinking humanly and being able to do all the possible kind of actions that a human can, which I think we're really, really far away, and it's still in the domain of sci-fi. Okay, so just to remind you again, AI is the field that exists for 70 years. If someone comes over and says they're a massive expert because they started 2 years ago, we call them early adopters, okay? We don't call them experts. Let them call it themselves, but you know better than that. Also, the history of AI in medicine started 50 years ago with the first expert system that actually at that point in time was much better than clinicians at those time in detecting what kind of bacteria causes a severe infection provided on the data it had, okay? And it's still kind of solving similar problems at the time. I'm going to point out, it solves a specific problem, a specific task, okay? Our lab has been long in this medical world of AI, and about 15 years ago we were a partner, and this is just one of the examples, a partner on a European project where we built a decision support system for cardiology. And this is a graph that maybe most of you have seen before. This is a history of AI in terms of how the popularity goes. And there was a first hype about 1970s, and obviously after the hype, what happened? There was a deflation of this hype. There was a massive disappointment because all kinds of promises were made on what it's going to do, and then it didn't. Okay? Then as the technology advanced, there was the next hype. Again, a period of disappointment. And I think since 2020, we kind of went all the way up here, right? And now the hype is the greatest. And the people are trying to project how far will it go. So linearly, based on the amount of data, I don't think that's the case, because the recent half a year showed us that technology advances can do a lot of new things. But also, I think all the promises about the general AI are completely blown out of proportion. And I think this is just creating this extra hype. And what history should teach us that after every hype, there is a winter, and that winter is not good for the field because it actually puts a black mark on the funding and on everything you're trying to do and popularity, etc. So I think this is very appropriate. Embrace yourself for the winter and try not to be the part of the hype, okay? Right, inevitable slide about ChatGPT. I'm deliberately leaving ChatGPT 3 here because this is a slide that is just under half a year old. What we did, we presented this to students of medicine and to practicing medical experts like undergraduates, postgraduates, and people doing the specialization. And what I always ask them is, if this is the training set of ChatGPT, do you recognize any kind of biases in there? Do you know what kind of bias could be there, what it learned from? Does anyone have an idea? Does anyone see the east of the world? China, all those countries? Do they even use Google? Oh, but they can translate to Chinese. Yes, they can translate, but the questions they ask and the way their lingual concepts work cannot be used unless you've actually seen them in the first place, right? So ChatGPT, among other things, is actually taught on the Western world's view of the world. That's one of the problems. The other thing is, what question did it answer? How to produce coherent and plausible text, right? Did it ever tell you anything about the correctness of that text? If you go on that website, it tells you a lot about, I mean, Corona is the best example, right? For a certain period, it was all about everyone is going to die. Then it was all about the vaccines, and then the vaccines were good and the vaccines were bad. And then you can apply that to homeopathy versus the classical medicine, all sorts of things. So depending on the volume of the text and the amount of text that it was learning on, it will just choose that text in certain ways, right? So we went from there to asking those same medical students, how do you use that ChatGPT? And we were also asking on the internet, I'm saying this is just pre-summer, how can medical experts use the ChatGPT? Okay, you can compress and storage information on electronic health records. If you have a lot of different documents, what it can do, it can write you a nice little summary of what this person has and has had in the past. Does that sound legit? I think it's really, really good use. It can compress, it can do real-time medical terms translations. If you end up in Norway and at some point something happens to you and you can dig out from your email your last checkup for your leg and this injury has exacerbated, what you can do, you can just pass it through and it will quickly translate it to Norwegian and doctor there can have in real time the information. I think that's totally legit. Diagnosis assistance was something that was used in and advertised as even in scientific papers in May and June. Clinical decision support, really? And there were other examples. This is where I took it from. Right. I don't think you can use it like this. And I think now, 6 months later, more and more people are realizing, even in the medical world, you can't. But this was the hype that was literally happening on a daily basis, and this was the topic we were discussing 6 months ago. I just want to put there in your heads what is the responsibility of AI experts when you come out and talk about it, okay? What you need to consider is privacy and security of what you do, responsibility, because you're usually putting in someone else's information, you're not the owner of that information, and how do you interpret the output? Do you believe it? Is it 100% true? Do you even communicate it as something that is a fact just because the model gave it to you, etc.? All right, okay, so just a quick overview on where we are in Europe on the level of AI regulation. Do you want to ask something, or no? Yeah? Because, so the question is, why is diagnosis assistance crossed over? Because the model is trained to make plausible and consistent sentences. It learns from a text which is not necessarily validated to be true. So if you take it as something that assists your diagnosis, then you're pretty much Googling it, which is not necessarily something that a medical doctor should do. I'm sure as a public, it's the same to you as Googling it, but as a medical practitioner, you shouldn't be doing it. You should be knowing which sources you're going to ask. At least ask an AI model that is trained on validated medical texts, and not on something that is learned from news media, etc. Right?
Apparently, there are some solutions that analyze X-rays for, I don't know, for cancer or this kind of stuff. That is obviously not text, that's visual, right? Probably. How is that logic applied there?
It applies there, but that's not a model that's been trained for something completely different. This is why I'm using an example of ChatGPT and exact cases that were coming to me from the medical world. So doctors, 3 weeks later, in one of the quite reputable Zagreb clinics said, oh, you know what I do now? I just ask it if one of the diagnoses seems legit or not. And you tell that to your patient, yeah, I do. No, you need to do so much learning to realize what you're doing is completely wrong. And I think the argument is we need to teach them what AI is, so they wouldn't use it the wrong way. Obviously, if something is being trained by an expert on images that have been labeled as cancer and non-cancer, and then actually does cancer detection on the images, and it has all the necessary metrics, then you know how well it performs. It's been validated by someone who knows the field, and therefore you can use it knowing how efficient it is, like anything else in medicine. But not ChatGPT, please. Okay, so where are we? At the same time, while this was happening, there is a huge talk about AI regulation in Europe, which frankly does not exist yet, right? It's being built at the moment. So there's this famous AI Act created by European Commission. It's being finalized for quite a while now. 2 days ago, I got an email from Ministry of Economy in Zagreb saying, this is yet another version, we want your feedback on it. And it keeps on going and going, and it's been kind of plateauing and never finishing for a while now. It's 108 pages long, and most of it is even not in there, it's in the annexes. And the idea that is pretty central, again, has to be communicated to the broader public, is that is a human-centric process. Nobody is really trying to get human out of the loop. So all the AI that will be developed within Europe should be human-centric. It should focus on accountability, trustworthiness, and explainability. And I think these 3 points well, the other two in particular, are something that should be very, very differently or very specifically considered in terms of medical application as opposed to other applications. Okay? Main debate, believe it or not, is how to define AI. So if you look at it, the Article 3 starts that AI is software that is developed with one or more techniques and approaches listed in Annex 1, right? And this is your Annex 1, which literally does a comma-separated list of the technologies that are now being defined as AI. And then a new technology comes out, and they go back and they try to define it, and back and forth and back and forth. So the technology is basically developing a lot quicker than those people sitting in Brussels can actually agree on, you know, are we accepting that or not? So this is one of the reasons why it's not done yet. Also, if you look at it, there's minimal mention of healthcare, health, medicine, or anything else. It's mentioned in very general terminology. And the only thing they say, it's a high-risk field. Of course, it's not the same filling in the shelves in a shop as basing your diagnosis on AI, okay? So let's go to those two concepts I quickly mentioned. This is not to be read. First, the concept of trustworthy AI. I think trustworthiness is something that is an absolute must, right? The AI produced to be used by the general public has to be trustworthy, but that is a really difficult thing to define, and there are all sorts of requirements defined that have to be met for something to be trustworthy. There is something called Altai assessment, which is envisaged as an online questionnaire, again standardized, where someone producing an AI product, in order to be labeled as trustworthy and get this badge in a centralized way, should fill out the self-assessment list. We've tried that. We actually tried that with a few products that were created in Europe, that is AI in medicine. They refuse to do it because they say the questions are too specific, and by answering some of them, they will actually reveal something that is considered a business secret, and therefore they don't want to do it. So there's clearly a disconnect with the good intentions and the practical applicability of that. So nobody will fill in the Altai questionnaire, which is what happens right now. We thought we could change that, but there's a clear reason why we probably can't. So that has to be thought over. Okay, the other concept is explainability, which has been a buzzword for ages now, and all the AI has to be super explainable. You have to learn exactly what the model does and how it does it, so you can learn from the model and it's not a black box, etc., etc. It's really good because it answers the questions, why did you do something, why didn't you do something else, when do you fail, when can I trust you, etc., etc. That's all nice and well in quite a few domains. I'm actually working, so my lab is a bioinformatics lab. I work in regulatory genomics. We work on those 98% of the genome that is not genes, right? Which was, when I was in faculty, considered to be junk DNA. Biology doesn't do anything that is junk. So what we do, we explore our genome, which is 3 billion base pairs, right? And clearly, there's AI approaches to explore what is the difference between you and me. By the way, it's about 3 million base pairs. And how can that affect your treatment, diseases, your genetic predisposition for certain traits and certain diseases. Right. In order to test for a paternity test nowadays, you need 24 pieces of that genome. 24 is enough to be 99.99999% sure whether this person or that person is the father of a child. We are querying 3 billion. Can you see why full explainability in a model is not good in that particular case? Because you will never get data which is anonymized. So if you have a data set and you ask too many questions, each person can always be uniquely identified. The way you can go about it is that you give just some of them and you keep them somewhere on a server, and AI runs there in a secure processing environment that the AI developer never has access to. So he sends his model there, the model learns something, and the model comes back. If that model is 100% explainable, by coming back, it will tell you also everything about the data you want to secure. Therefore, secure processing environment is not secure anymore. So there's a clear case where this can be considered in a black and white world the way the rest of the AI community is looking at it. Right, quickly. Secondary use of health data is something that is absolutely, in my opinion, the crucial point that the whole Europe fails on. We have the data, it's produced, it's not being used in research, innovation, or anything else. Medical imaging data that you mentioned grows probably largest of all. The numbers are really, really high. However, again, not a lot of research has come out of it, at least not proportional to the amount of data is being used. Europe is trying to sort that out. Again, people in various consortia have created European health data space. The idea is people don't know where their data are, and people are owners of their own data, right, as patients. People, healthcare professionals, don't know where the data of the patients are and whether they can give them to the patients, which sounds stupid enough, but it's true. Also, healthcare professionals don't know which information can they share with different healthcare professionals, what is allowed, what isn't allowed. And these rules are very difficult to create, and they should be created on a pan-European level. And the third of all, this part down here, at this point, is completely oblivious of all the data and cannot access that data, which means our policies are not evidence-driven, which means our regulators do not see the specific statistic they should be basing their new laws on. And it means that research and innovation really can't do a lot of research and innovation because they can't access that data. And this is just the numbers of the benefit that will be in 10 years' time, provided European health data space sets out those sets of rules. I see the same future as AI Act to it, okay? This is the map of how Europe is in terms of development of policies and implementation of policies. Croatia is here. This has been done by Roche, so it's a pretty arbitrary set of countries here. And we are considered to be of a limited vision, which means we have very basic policies, but we are really good at implementing our very basic policies. This is some European examples of all different secondary health data that has been put out there for research and innovation, right? But what I wanted to point out that in Croatia we have a white paper. We have actually created a white paper specializing what our problems are and suggesting some of the solutions. As of creation of our EDIC, we have actually started a data group of 7 partners that meet on a weekly basis until we find out a way for our startups and public sector organization gain that access in a reproducible way to Croatian data. And also our Croatian Institute of Public Health is actually part of the pilot of European Health Data Space. It actually is involved in developing that regulation. Right. I'm going to quickly go through that. So I would just want to point out, without this data, none of these processes later on are important, but I'm sure you're aware of that. A really important question in medicine is who does the data cleaning and data wrangling. At this point, everybody goes back to the hospital and says to the doctors, clean up your data. They don't know how to do that. You need to teach them, or you need to have specialized people working in those hospitals to do that. There is no big data until data are harmonized, standardized, and interoperable. I know, yeah, quickly. So there's various measures, and we need to be very careful about which measures we use, especially for the medical purpose, okay? By applying all of these principles, you can improve your data sets, but it needs to be done, again, by the whole team and not by one person. Also, this is something that needs to be trained to every person who does AI in medicine. You need to see that only half of your data in this particular case is from your big data set, the basis that you learn on. And also, you need to be able to validate in real world. Okay, Croatia AI examples. We have a speech-to-text technology that is actually living in our hospitals, which is really cool. The same speech-to-text is used in Serbia as well. It actually speeds up typing up the data, and is developed by Newton Technologies Adria. We have tested and piloted the technology that actually, Polish technology, that exists, that actually detects atrial fibrillation based on really huge amounts of ECG. Nobody uses it in Croatia. They don't know it's there. They don't know it's good. Why they don't know it? Because they've never seen it before. We paid for them to play with it. So they learn that it's better and that it saves them time, so they at some point actually adopt a new technology on a pilot of 100 cases. There is a digital assistant being developed that actually talks to the patient on a daily basis and says, measure your blood pressure and measure your heartbeat, put it in the text box. She's called Maggie, and she's really sweet. But it then creates a data set behind it that is communicated to the specialist, and it actually reminds the person to be a proactive actor in treating their chronic hypertension. This is just a list of services that we do. I'm not going to go through that. It's online. How we actually create this ecosystem and what we provide for those users. And just to go quickly over the topics we talked today, about AI models in medicine, I think what we need to do is to build a toned-down public face. Don't get super excited. Don't get the wrong hyped-up messages across, because otherwise you will be called later on for the BS you provided, and also the whole field gets degraded. Regulation is out there, it's being created, but it's being created in little black boxes. Healthcare, AI, it needs to be put together. Secondary data use of healthcare data is about ecosystem and working in teams. And we are piloting, and we're at the very beginning, but we're not getting very far with it, at this point. But we have 3 million euros to change that. Okay, I think responsible AI use has a place in medicine. Try it again, a million times said today. Educate. Educate yourselves about a domain you're not an expert from. Nobody is the unicorn. Also make sure to educate other people. Try creating academic courses. Try to create informal education, online education, all different kinds of education. Be out there. And also participate, and make sure the medical people participate. Unless they gather the data, we don't have anything to learn from. Thank you. I think we have time for a few quick questions or discussions or comments even. No? Still too early in the morning for everyone? Okay. No, come on. Yeah.
Hello, it's really great. I think we're actually working in Serbia a lot on similar stuff, especially related to data. Maybe not so much about AI. But I wanted to ask for the Croatia, what's the situation with, you say, digitalization of healthcare, but what that means? Is there a centralized repository of health data? Is there electronic health records?
Centralized. It's a few centralized, they don't talk together. There is a primary, secondary, and emergency. So emergency doesn't know if you're vaccinated or whether you're allergic to something. But that's an effort in its own right, and it's been dealt by Croatian government. So there is an e-health and digital health projects that we didn't want to necessarily barge in and take away their glory. But we are building on top of that and saying this is where AI can help, and this is what we need to develop that, because ICT industry is willing, but they're kind of avoiding healthcare because it's a high-risk field. So it's kind of creating that dialogue. But like I said, we have e-prescription, we have e-referrals, we have our payment is centralized. There's a lot of data in that system. Some of these systems are actually of age. They're well over 18 years old. There's a lot of segmented data in the system that what we are trying to do now is actually open it to the research community and define the rules how to open it to the research community. Anecdotally, you can open it internally through the ministry. If that service asks that service, then someone does an SQL query, and then a lot of paperwork needs to be filled for that one SQL query to actually go out. But that also needs to be streamlined, because it's not a matter, it's not failing on the technical part, it's always failing on who can access what and what is the rules.
Yeah, exactly. That's just my second question. Is there a regulation that's already done in Croatia related to secondary usage of data?
There is a white paper. The regulation is European Health Data Space and is being created pan-Europeanly. The way they do it is they have 5 pilots. I should probably know how to name all of them, but one is the inflammation spread, one is something to do with cardiology. Basically, they took 5 very orthogonal cases, and they said, okay, let's do everyone who does on secondary data use in your various EU countries, and have them work in teams on those 5 pilots, and if we solve, to some extent, those 5 pilots, they will be the baseline of the European regulation, because they will cover enough different cases. And this is the same way the AI Act worked. But even if they get to the very end, what is going to happen is with AI, what happens with AI, they're going to spend next 5 to 10 years defining specific words inside, and it will not come out as a proper legal document. And then the same thing as GDPR, every country will implement it slightly differently. So what we're trying to do, EDIH will finish before actually EHDS actually starts. That's at least my view. They say that it won't. So what we're trying to do is locally pilot a few small, easy cases for at least some of the industry to start picking up on.
Okay, a long way ahead.
Yes, but now actually we have the money, because every time the argument was, yes, we've been talking about it for 15 years, but everyone's fighting with everyone. Like, right, you need to sit around the table. Second one is, we would put that module in, but there is no money and nobody asked for it. Here's the money. So we're slowly trying to chip away those little barriers and be enablers of the whole system. We're not inventing anything new.
Yeah, okay. And just, I'm sorry to monopolize, but just one more. It's related to genetic data. Is it the regulation related to genetic data or storage of this data?
I think not even Europe is doing it in a regulated way. I think it's more like little islands of people who are doing the best they can. There's different societies that actually try to figure that out, but the practices are at this point very, very different. I think it's going towards federated learning, data lakes which are secure and protected and never leave the country, never leave those spaces, and then defining the modes, how you can actually access that data over there, and what are the rules, and what can you access, and on a case-by-case basis, at least in our case, define. But we're not even touching genetic data at this point. I would. I mean, frankly, this is why I actually want to see this consortium go to the end, because 10 years down the line, it will facilitate my research from the Croatian genetic data that I have. I know where it is. I can even go in and probably see it off the record, some extent of it. I can go and query some things, but I'm not going to do that because ethically it's wrong, and also there's no regulation behind it. So I can work on, NIH data and public repositories, but I can't work on the data and people who can actually benefit from that. I'm sure even later on today, you're going to hear a story about one rare disease where there is medical data, genetic data existent, but you can't get to those cases. And we researchers that work genome-wide, we cannot. This is clinical geneticists can work on a simple, case-by-case basis. We could provide a lot of information, but we just need that. It's lying around the world, and it's super useful. But I think that's somewhere at the end of the whole bridge.
Okay, thank you.
Is that it?
Thank you, Anja, for this very insightful talk.